So, hello everyone. Welcome back to the video series on software engineering. That is basics of software engineering. So, in this particular session, we are going to study about the evolutionary process models. And before we have actually studied about waterfall model and incremental process models. And incremental process models, we have actually defined two models. One is called incremental process model and RAD, that is Rapid Application Development Model. So in this video, we are going to see about what is evolutionary process models and what are types of evolutionary process models. So as the requirement often changes as development proceeds, that means sometimes it happens that the customer as well as the developer both doesn't have actually the knowledge or the overview of what has to be developed or what needs how it is to be developed, both the cases. So evolutionary models are iterative, that means they have iterations, that means they can have, you can go back and back in a loop and you can enhance the product. However, they are characterized in a manner that enables software engineers to develop increasingly more complete version of the softwares. So, what is the motive of evolution process model? Is that the nature of developing something in each iteration they add more information. Okay, in each iteration they get more and more level of information, and that information actually enhances the system. The analogy of this is as the evolution of a human being. Like when you were a child, you doesn't know many of your the things. You don't know how to talk. You don't know how to walk, right? But with each iteration, with each loop that you go through, you learn every single cognitive skills, right, that are very very human in nature, from your parents, your surroundings, and the things you see, the things you touch, and the things you feel. You learn each day, so you evolve with the time, right? Likewise, software also evolve with time, and they actually learn. Okay, sometimes this learning is very human centric, that human learn and then apply. Nowadays they are machine that actually learns, and if the machine learns they can again enhance their workflow. So the type of evolution models are, first is prototype model, and the second is spiral model. Okay, so we will go one by one and we will discuss both these type of models. So, prototype model paradigm is used when a customer defines a set of general objectives for software, but does not identify detailed inputs, processing, and output requirements. Likewise, a customer actually have just an overview that what this is what I want. Okay, but he doesn't know what is the input he is going to give, or he has a very vague set of uh, knowledge about limited set of inputs that he wants to give, and he know that what he wants, but the format which he wants, or what can be the complexity of the outputs, he doesn't know. He doesn't know how the thing will process inside, or what are the steps that are required to process an input to processed output. He doesn't know anything. Likewise, the developer may be unsure of the efficiency of an algorithm, the adaptability of an operating system, or the form of the human machine interaction that needs to take place to convert the input to the output. So in this prototype paradigm, the both the customer and the developer, they don't have an actual total understanding of the system. So we can say the parameters that we have actually identified, that the requirement should be stable and the requirement should be well understood. Both these parameters fail when we are going to choose for an evolutionary type of process model. So this is the workflow of a prototype model. In this, you can see that it starts with a quick plan, That means whatever requirement it start with communication. Before that, there's a word thing called communication. So communication is the starting point of a particular type of any model or any process. So we start with communication with the client. We gather the requirements. Now, when we have the requirements, we will quickly plan the first release or the a certain thing that he wants to see. So what we do, we call it is a quick plan. So the quick plan actually has almost those all those requirements that are actually needed by the client. He wants to see that requirements. He can just then he can just like he wants to see a GUI, or he want to see some data. He wants to see some images or videos that are getting processed with the help of the software. So whatever is the requirement of the client, those requirements that you can fulfill at the earliest, you take them in a quick plan. Then the second stage is modeling a quick design. That means you will actually plan out the diagrams or the requirements that are needed for quickly implementing this plan. Then you have a quick construction of a prototype. So the prototype is you can say we will see what is the prototype, but right now it's a working model sometimes. So it is a working model which actually resembles the actual software, but it might not be an actual software. So you create a prototype, you deploy or you show that prototype to the customer. Once you get a positive feedback, you again start development, or you can go back to communication stage and you again refine the prototype. So you keep on refining the prototypes so that you can get a better idea what needs to be developed. So this is a workflow for a prototype based model. Now, the prototype that we were talking about. So prototypes are a particular sort of softwares that actually help us to understand the actual requirements. It can be categorized into two types basically. The one is called the working prototype. In working prototype, the developer attempts to make use of existing programs, okay, existing program fragments, or applies tools that enables working programs to be generated quickly. So I can say today we have IDEs, we have Python libraries, we have a lot of packages available. We can just put in all these packages at one place. We can create in a very small amount of time. We can create a working model sometimes. So it is not the actual software, but yes, the user when it sees the GUI, they see the labels, they see the text, it sees the workflow. He can find out, yes, I want such this type of software is really fit in my requirements. So he will give you and go ahead on this. So what you do, you then enhance this prototype to an actual software. Okay, you don't throw this away, but you will keep on investing on this prototype. You keep on updating the prototype from a simple stage to an advanced stage, and you deliver a complete software. So this is called as working. When you create a simple programs, based on the simple programs, the when you get a good positive feedback or you get reviews, you keep on updating that particular program till you have a working software in place. So this is known as a working prototype. This type of software, generally these things we actually see mostly in software development also. It is requirement of industry as well. When you build a car, suppose you show a prototype, so it is a huge investment to make a dummy model of a car. So if you want to throw them away, it's very costly. So what you do, we show certain structures of the car, we show certain diagrams of a car, then we actually enhance the diagrams or the structure to actually build a actual car in that case. Okay. The second type of prototype model is called throwaway prototype. In most of the projects, the first system build is barely usable. In such a case, the prototype, once approved by the customer, may be thrown away and the developer have no alternative but to start again. So sometimes it happens that you build a HTML based website, okay, an HTML simple website, but the actual website today doesn't deploy just HTML. Okay, it has advanced software development tools and technologies. So what you want from the basic HTML? You want the customer to see the look and feel, because customer doesn't know the in and out of the website. He actually sees the GUI, and when he sees a GUI, he feels comfortable. When he feels comfortable, and the workflow when you show by interlinking the pages, he feels that okay, after this page, the second page is coming correctly, the text is coming correctly, the labels are correctly. So what you do, you have hard coded or you have actually written down in the HTML file. It's a static pages. Oh, so you show him the static page, so he approves the look and feel, the data that is being viewed in that particular context. Once you understand that this is what he wants, you can actually throw away the HTML type and you can start away with the actual implementation of a new advanced technologies, adhering to all the requirement that you showed him in form of HTML. Now this is known as a throwaway prototype. So the drawbacks of prototyping is the customer sees what appears to be working version of the software. So the thing is, you showed him something and he understood that this is actually uh, what you are going to build. However, when informed that the product must be rebuilt so that the high levels of quality can be maintained, customer generally demands. Okay, you need to inform him that I'm going to build it from scratch again, so that I can implement with the system with a high quality standard like how security features and everything else. The developer often makes implementation compromises in order to get a prototype working. Sometimes what happens is you actually want certain labels. Customer wants, okay, I put this label here or could put this text here. What you do, you hard code those text easily, and in the rush of developing a particular type of software, you actually forget to remove the hard coding. Okay, so at the end, when you create a software, the hard coding is a problematic that comes up. So you make certain compromises in creating a prototype, and those compromises actually leads to the errors in the software. So these are the two basic drawbacks of prototyping. Now, before going ahead, we will see certain questions that we actually have discussed in the previous lectures, or you have studied in your previous in the courses in your classes. Uh, then we will proceed with the next prototyping model, which is called a spiral model. Thank you very much.